Ladies and gentlemen, welcome back to the YouTube channel. Today I would like to show you in LibreOffice how to simulate an on-off controller. How is it working? We will imagine a basic puffer tank, a cross-flow tank. The equation is very simple. The setup will be this way, that we have a puffer tank and inside that some liquid, let's say oil. We pour oil on top and it will leave in a tube at the bottom. Some block arrow going down will represent the stream filling the puffer tank. Change to yellow, and then another one to right side, it will represent the leaving oil through a connecting tube at the bottom. We would like to calculate the level of the oil in the puffer tank. To be able to do that, we need some equations. First, the driving force will be the balance between the potential energy, mass times gravity acceleration times height, and the kinetic energy, half times mass times velocity on the square. So this is the basic equation you can see here. But we need the velocity because this will tell us how much oil is leaving at the bottom. So if we express the velocity from this, the mass we can simplify here. The 2 will go to the other side. So the square root of 2 times gravity acceleration times height. And now we can define how the the oil level is changing in the puffer tank over time. We need an input stream, the oil coming in, minus the output. But the output stream, we can already say that it is the connected cross section of the tube, the hole, and the velocity through the hole which is leaving. So the tube area times the velocity, which we just calculated earlier or expressed as the square root times gravity acceleration times height, and then everything is divided by the base area of the puffer tank. So now you can see that this is the equation where we can substitute some constant values: the surface area, the bottom surface area of the tank, the tube cross-section area where the oil is leaving, and the input stream. These will define together what will be the level. Of course, the input level will increase, the leaving stream will decrease the level. So we need the constant values. The input should be in liter per hour. This is a common unit how they are measured. For example, 800 liter per hour, it is the value how we can see the water coming out if we open the tap completely. But we need in meter the calculation, so it should be cubic meter per hour. So this will be divided by 1000 because 1 cubic meter is 1000 liter. And 1 hour is a bit long. Maybe we should use smaller steps in the simulation, let's say minutes. So I will divide by 60 because in 1 hour we have 60 minutes, cubic meter per minute. This will be the value what we are going to use. The diameter of the base, let it be 28 centimeter. It is a common size at household. Your pot or maybe the pan has this size. Again, if I divide it by 100, I change to meter, and then the base area, now I can calculate easily based on the diameter, 0.25 as 0.25 because I have to divide by 4 at the end, the pi multiplied by the square of the diameter divided by 4. So multiplied by pi, and then this on the square. This will be in square meter, the base area. The same we should know for the tube. The tube diameter will be, let's say, 1 centimeter. These equations I can copy down. And now you can see the change to meter and then the area of the tube. Now basically the input stream, tube area, base area, we have all the constants we need. And the time step also, because if we want to express the level change, the oil level change, then we need the time as well. So it will be in minute. At the beginning, let it be 1 minute. We will see. If it is necessary, we can still change. To be able to compose the equation easily, I use names. For example, here is the input stream cubic meter per minute. I will call it Q input. And you will see that here will be a list of names in the spreadsheet. So this will be the base area. This will be the tube area, the cross section of the tube. This will be the time step, the minute. Okay, so finally, if I check the list, you can see that all the parameters should be here. Yes, the base area, the tube area in the same unit, square meter, input stream cubic meter per minute, and the time step in minute. So first, we should know whether this system is going to steady state. Is it a stable system or not? So the time in minute will come from 0. It will be the beginning, the initial value. The level of the oil will be 0, empty tank at the beginning, and the change of the meter we can calculate by the equation. The next row will be very easy. The previous time plus the change, the time change, dt minute. And then I copy down minimum, let's say 500. It looks nice. Okay, so now I have it in minutes. And then I can calculate the change here. The time I have to put the other side to leave the level change only here. So time change multiplied by the input stream. You can see that the name already appears as I start typing. This is why it is very easy to work with names, and the equation will be easy to read, better than what is in the given cell with the coordinates. It's better. The tube area multiplied by the square root of 2 times gravity acceleration, not 10, be careful, 9.81, times the water level. The current water level is here at the same row, and then everything is divided by the base area. And now we have it. The next row will be the previous level plus the previous change. I copy down. This also I copy down. And now you can see, we can check from the water level we calculate, and it is easy to read the equation, exactly the same. So now if I choose this column first and then the next one together, I can make a plot and see how is the water level. Oh no, this is the change, maybe. Oh yes, this is the change. I don't need it now. I need this, the level of the oil. Sorry, not water, oil. Just many people calculate for water, and this is why I also say water, sorry. So let it be. Where can I add the figure, chart, insert a chart, a nice chart. Okay, let's check the wizard. So I need a scatter connected with lines. Next one. Okay. And then I think we can finish it. Maybe it can be a little bit beautiful, this figure. If I modify a little bit, we understand what will be on the figure. So maybe I can add title, it is better. Insert titles, and the x-axis will be time in minute. The y-axis will be the level in meter. Now it is better. And then format major grid. It should be ultrafine dotted. Maybe that's better. And then regarding the grids, maybe the major X grid the same. If I change it, ultrafine dotted, then we can see how it is. So this is the level. Now we can see that with these parameters, actually few minutes are not enough. Oh, even 500 minutes is not enough to reach the steady state. Aha. Maybe 1 hour is not a bad idea. Let's check what happens if I change to 5 minutes, 10 minute steps, 15 minute steps. You can see it starts to get curved shape. 30 minute steps, it is getting curved. A bit slow, but get. And the only problem is that it is very high. You can see that basically this will have a steady state somewhere around above 1000 meters. Okay, so the system is stable, but the hole is very small, so very small amount of oil is leaving. If I want to put it into a technology line, no building will be higher than 1000 meters, so we should control it somewhere. Maybe in 1 minute step you can see that even 10 meters is very high. Maybe we can get the upper lower level and we can put a controller there. How it will work? So we need limits. So the controller will work that way, the upper limit and the lower limit. The upper limit, let it be around 2 meters, 2.3, and the lower 1.7. It will be symmetric somehow. And then I would like to decide how to operate my controller and then manage the change in the filling. So I have upper limit and I have a lower limit. I added new names to the list. So first I should be able to decide how the controller is working, whether I am in the good level or not. So what should be the control? Of course, if I am lower than this level, the controller should work. So if the current water level is lower than the lower limit, then the controller should work. Otherwise, no. This is very simple. It is easy to understand, but what should happen if I am, for example, above the upper limit? If I am above the upper limit, I should turn off. It is again something to check. So first I check if I'm below the lower limit, then I should turn on. If I am above the upper limit, I should turn off. It will be 0. Otherwise, what should happen? By default, let's check, the default value will be that we fill the puffer tank. Okay, so this is how it is decided now, that the controller will say that we fill the puffer tank or not fill the puffer tank. For the first, it is completely fine. For the second, it is a bit more difficult question, because what will happen if I am between? This should be more easy, more sophisticated. If I am below the lower limit, I should fill. If I am above the upper limit, I should stop filling. What should happen if I am between? If I am between, I should continue what I did before. This is very simple that way. So here you can see that until we reach the limit of the upper limit, 2.3, then we still fill, and then it stops filling. It is okay. So the controller is simply turning on, turning off, not adjusting the input stream, just turn on completely or turn off completely. No between. Okay, now if I want it to work in my equation, I have to modify it. The input stream will be multiplied by the control value, which is in column D. Unfortunately, now it is covered by the equation. So D and 16. And now, if I change it, you can see how it is working. You can see the controller is turned on and off. And this is the water level change, and then this is the height. The height is increasing, and when it is going below 1.7, yes, then it should 1.7, and then it is turning on again, very short time, because the input stream is filling very fast. So you can see that only for short time it is done. We can add a second figure to this to represent the controller. So I will mark it to see that the two figures are moving together and they are connected. Okay, go up, 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 up. Okay, and now if I insert the second figure, again scatter, connected. Okay, finish. Ultrafine dotted, the same like the others. And then here you can see the controller is only turn on, turn off, so no level between. I can insert maybe the titles again here. The x-axis is time in minute, and on off signal. This is the control signal, and here this I can move below the other. Oh, I didn't want to jump too much. Maybe here. If they are together in one figure, maybe they fit one screen, you can see, I hope they are aligned the same way. So when it is jumping, then I could add to a secondary axis. That would be more elegant. But now you can see on two different figures how the controller is working and affecting this control. And then the water level is adjusted based on the limit we want. So thank you very much for your attention, and have fun with playing with LibreOffice and meet the process control.